Lesson 9-6, okay, multiplying a polynomial by a monomial. Before we go to the lesson proper, let's take a look at the 9-6a, how to multiply a polynomial by a monomial by using algebra tiles. Okay, so you have used rectangles to model multiplication. In this activity, you will use algebra tiles to model the product of simple polynomials. Again, algebra tiles are useful only for simple polynomials, because when the polynomials become bigger, it will be impractical to use algebra tiles. So let's take a look at this one. This is a visual way of finding or looking at how polynomials are being multiplied. And it is also a visual way of saying that when you multiply polynomials, you're basically finding the area of that particular polynomial, and you're making it into a rectangle. Okay, and we're using the formula of area of a rectangle, which is area equals length times width. Okay, so the width and length of the rectangle will represent a monomial and a polynomial respectively. Okay, the area of a rectangle will represent the product of a monomial and a polynomial. So we are just in this particular lesson, we're simply multiplying a monomial with a polynomial. So let's use an algebra tiles to find x times x minus 4. Okay, so x times x minus 4. Remember when we discussed when we started discussing uh, algebra tiles, we got the area of an algebra tile by multiplying its sides for this square. So this length is x, that length is x, that's why it gave you x squared. In the negative x tile, okay, this is a negative 1 or an x right here. So the width is negative 1, and you end up with a positive x on the length to give you an area of negative x. Okay, so let's use this skill to be able to multiply x times x minus 4 using algebra tiles. So the rectangles will have a width of x units, okay, and the length of x minus 4 units. So you'll have the length of x units, that's your x right there, okay, and a width of x minus 4, and this is how we represent x minus 4, 1x, and 4 units, that becomes negative 4. Okay, so mark algebra tiles to mark off the dimensions of on the product map and make the rectangle with algebra tiles. So basically what we want to form with x times x minus 4 is a rectangle. Okay, so first we know that x times x will give you an x squared tile, and that's where we put it there, right there. Okay, and we know that x times negative 1 will give you an x tile, which is this one. Okay, and x times negative 1, another x tile right there, x times negative 1 right there, and x times negative 1 right there. Okay, so we have formed a rectangle. If I do this properly, this should look like a rectangle. Okay, there you go, it looks like a rectangle. So what do we have? We have x squared minus 4x, because there are 4 red x tiles. Okay, so it gives us this one, x squared minus 4x. So the rectangle consists of 1 blue x squared tile and 4 red x tiles. Therefore, x times negative 4, or x times the quantity x minus 4, is equal to x squared minus 4x. Okay, let's take a look at activity number 2. Use algebra tiles to find 2x times x plus 2. Again, in this case, okay, that'll be x, and that'll be x, and that'll be 1, and that'll be x. Those are the dimensions of the x tile. These are the dimensions of the x squared tile. Okay, so 2x means 2x x's. Put that on the horizontal column. Sorry, vertical column. In the horizontal column will be x plus 2, x plus 2 unit tiles, and we simply start multiplying them. X times x will give you, okay, an x squared tile, Okay, and x times x again will give you an x squared tile right there. Okay, and x times 1 will give you an x tile. Let me line this up first. There you go. X tile, x times 1 will give you another x tile right there. Another x tile right here, x times 1, another x tiles. So if I fit this properly, I have just formed, okay, more or less a rectangle right there. Okay, so that's our rectangle. So if you notice, that's 2x squared tiles and 4x tiles. So that means 2x squared plus 4x, like this. Okay, so the product of 2x times quantity x plus 2 would be 2x squared plus 4x. Okay, and we can probably do the same thing with these ones. You can try this on your own. Use an algebra mat to be able to find the product using algebra tiles. Okay, so let's go to the lesson proper. In the lesson proper, we want to multiply a polynomial by a monomial. In this lesson, you learn to multiply a polynomial by a monomial and to simplify expressions involving polynomials. Why is it important? Because you can use monomials and polynomials to solve problems involving travel and recreation. Okay, so let's take a look at this real-world application in recreation. Have you ever played the game hopscotch? Children from all over the world like to play some form of this game. The following diagram show versions of from different countries, from France, from Nigeria, from China, okay, and from Trinidad. So on the Caribbean island of Trinidad, the children play Jumbi. The pattern for this game is shown at the right. Suppose the dimension of each rectangle are x and x plus 14. So all of these are x and x plus 14. Find the area of each rectangle. To be able to find the area of each rectangle, okay, you must multiply the length by its width. Okay, and we can make two types of diagram for this one in the game Jumbi. This diagram of one of the rectangles shows the area x times x plus 14, because this can be x, and this is x plus 14, which will give you the product of x times x plus 14. Okay, or we can break it down. Okay, this diagram is the same rectangle, shows the area x x squared plus 14x. Okay, so if I erase that and simply show you what that is right there, x plus 14 and x. Okay, and this is the same one. Why? Because this can be x and that can be x, which will give you x squared. Remember our algebra math. And this can be 14, and multiply that by x will give you 14x. So again, same same product, same rectangle. Since the areas are equal, okay, we know that x times x plus 14 is the same as x squared plus 14x. Okay, so this illustration right here shows you what property. Of course, the distributive property. Okay, you can use the distributive property to multiply a polynomial by a monomial. Okay, so to find each product, we use that same property. Okay, but let's use two methods this time. We want to multiply 7p times the quantity 4b squared minus 18. We can either multiply it horizontally or vertically. Okay, let's do horizontal multiplication. In horizontal multiplication, we apply the distributive property 7b times 4b squared, 7b times negative 18, okay, will give us 28b cubed minus 126b. Okay, again, how do we know this is in simplest form? Because we don't have like terms. Okay, method 2, no parentheses and no like terms. In method 2, we do the vertical method. So we simply multiply vertically. We first multiply 7b times negative 18, like that. Oops, that. And multiply 7b times 4b squared. And we still end up with the same thing, 28b cubed minus 126b. Okay? In letter B, negative 3y squared times the quantity 6y squared minus 8y plus 12. Okay, so we copy the problem first and foremost, and we use the distributive property or method 1 for this one. So we distribute negative 3y to 6y squared, negative 3y squared to negative 8y, and negative 3y squared to positive 12. And this is the result. Negative 3y times 6y squared, negative 3y squared times 8y. See, the subtraction is still there, and negative 3y squared times 12. Okay, simplify that further, end up with negative 18y to the fourth, 24 plus 24y cubed minus 36y squared. Okay, again, it's in simplest form because there are no parentheses and there are no like terms. Okay, so some expressions may contain like terms. In these cases, you will need to simplify by combining like terms. So let's take a look at method 1 again. In method 1, multiply first and then simplify by combining like terms. So we need to multiply and then we need to combine like terms. Again, we go back to our distributive property. First and foremost, we need to copy the problem. And then we go to our distributive property. And in our distributive property, you're simply distributing negative 3p cubed to p squared cubed to 2p and negative 3p squared cubed. Okay, you end up with this. Negative 3pq times p squared q. You distribute the negative 3pq to 3 terms, and that's how you got these. Okay, these terms right there. Simplify those terms, you end up with negative 3p cubed q squared minus 6p squared q plus 9p cubed q squared. Okay, again, we are still following this time, applying the rules of exponents. We'll learn that. So I hope you haven't forgotten that yet. And we start adding like terms. So what do you notice? Okay, we have a like term. To make this line permanent, we have a like term here and here. Why are they like terms? Because they have the same variable with the same exponent, p cubed q squared. So add those two, end up with 6p cubed q squared minus 6p squared q. Simply bring down 6p squared q. Okay, method 2. Okay, we combine the like terms first and then we multiply. Okay, so if we combine the like terms first, copy the problem, combine the like terms p squared q and negative 3p squared q, we end up with negative p squared q and 2p. Okay, so we combined these two terms right here, this one and this one, end up with negative 2p squared q. And then we simply use a distributive property. We multiply. Okay, multiply by using the distributive property. Okay, and that's what you get here. And then you end up with 6p cubed q squared minus 6p squared q, which is the same as we got in method 1. Okay, by combining our like terms first and then multiplying it second. Okay, let's take a look at example number 3. The runners in a 200-meter dash race around the curved part of the track. Okay, so the runners in a 200-meter dash race around the curved part of a track. It is not a sentence. So the runners are Well, basically these are the runners in the 200-meter dash race around the curved part of the track. If the runners start and finish at the same line, the runners on the outside lane would run farther than the other runners. To compensate for this situation, the starting point of the runners are staggered. If the radius of the inside lane is x and each lane is 2.5 feet wide, how far apart should the officials start the runners in the two lanes? Basically what it's saying is this. So these are your starting lines, and the reason why the runners on the outside track start farther from the start line than, let's say, the runner from the inside lane is because this runner needs to travel farther, okay, than the first runner. So the runner in lane 1 would travel a shorter distance compared to the runner in lane 1, 2, 3, 4, 5, 6 in lane 6. So to compensate for this, okay, they put the runner in lane 6 ahead, okay, of the runners in lane 1, okay, and so on and so forth. So what it's asking is this: how far apart should the officials start the runners in the two inside lanes? So the two inside lanes are this: lane 1 and lane 2 are the two lanes that we need to worry about. So first things first, we need to find out we need to know the circumference of a circle. It is assumed that you know the formula for circumference of a circle, which is 2 pi r, okay, where r is the radius of the circle, the distance around half of the circle. The distance around half of a circle is pi r. Why? Because we multiply 2 pi r by 1/2. That cancels out 2. So the distance around half the circle would be pi r. Okay? So we want to use this information to find the distance around the curve for the two inside lanes and subtract the quantities to stagger the distance. Okay? So that's what we want to do. Okay? So we want to find the distance around the curve for the two inside lanes and subtract the quantities to find the staggered distance. Okay? In order to do that, okay, we need to know the outside semicircle, okay, circumference, half of the circumference, which is pi times quantity x plus 2.5, y 2.5, because that is how wide each lane is. Okay, so subtract that with pi x, because that's an inside semicircle. So this is your inside lane, that's pi x, and this is pi times quantity x plus 2.5. Okay, so using the distributive property, we end up with pi x plus 2.5 pi minus pi x. Okay, so if you notice, these two are like terms, pi x minus pi x, and then we simply take that out. The pi x cancels out, we end up with 2.5 pi. Okay, by combining like terms. So the two runners, okay, should start 2.5 pi, or about 7.9 feet apart. Okay, and that's how you figure out the staggered distance between the runners, and so that nobody would be at a disadvantage when they start the race. And final example, many equations contain polynomials that must be added, subtracted, or multiplied before the equation can be solved. The distributive property is frequently used as at least one of the steps in solving equations. So we want to solve this equation by x times the quantity x plus 3 plus 7x minus 5 equals x times the quantity 8 plus x minus 9x plus 14. So we want to solve this particular equation, and before we do that, we need to simplify both sides of our equation. In order to simplify both sides of the equation, remember when an expression is simplified. Okay, so an expression is simplified when there are no like terms and there are no parentheses. So we need to do that first for both sides. Okay, so we use the distributive property. Okay, copy the problem down, use the distributive property. You have x squared plus 3x, distribute the x2, okay, We're distributing the x2, x and 3. We're distributing x2, 8 and x right there. Okay, using that, you end up with x squared plus 3x plus 7x minus 5, x squared plus x squared minus 9x plus 14. Add the like terms. Okay, remember we need to simplify both expressions first. That's a like term, that's a like term. Okay, that's a like term, and this is a like term. Okay, so you end up with x squared plus 10x minus 5, x squared minus x plus 14, combining like terms. And then we get rid, because we now have x squared plus 10x minus 5, x squared minus x plus 14, we get rid of x squared. We subtract x squared to both sides of the equation. Okay, subtract x squared to both sides, x squared disappears. You now have 10x minus 5 equals negative x plus 14. You now have a variable on both sides of, okay, the equation. And we need to undo one of the variables. We undo one of the variables by adding x to each side. If you add x to each side, you get rid of negative x. End up with 11x minus 5 equals 14. This becomes a simple two-step equation. Add 5 to both sides, divide both sides by 11. Okay, so the solution is 19 over 11 for number 4. Okay, and the secret word for this lesson would be Bruins. Secret word is Bruins. And that's the end of our lesson. Thank you for watching.